trends across period 3 elements. So I will very fast draw the table here, the periodic table. We said it is very important to know how to sketch it by yourself. That is what I'll be doing. The third column is made of transitional metals. So that is okay. Let me shade this. If maybe in a paper it is not shaded, it means that it has been left out. But in most cases, they'll include it. 1, 2, 3, 5, 6, 7, 8. 8 is that way. We said we have up to four periods. That is what we'll be learning at this level. 4 periods. That is the first one. So periods are horizontal arrangements. The second one is over here. In the third one, containing only of 2 elements. Then we will only name let us only name the period 3. We said periods are these horizontal arrangements. These are groups. Group 1, 2, 3, 4 groups. We said they are named using Roman numerals. Periods named using the number system. Number 1, that is period 1. Period 2, and our famous and anticipated period 3 is over here. That is period 3. And then you have period 4 here. Let us name period 3. Period 3 starts with the element that got 3 energy levels, and that is what we said a period signifies. A period shows the number of energy levels of an element, of an atom of an element. Each one has 3 energy levels here. Oxygen is number 8, 26, 27, 28 for neon to get 10. Sodium 281. Good. We'll be starting with sodium. Number 9, sodium. First, number 10. Oh, sorry, not number 9. What did I say? Number 9. Sodium is number 11. Number 12. Number 13. Number 14, 15, 16, 17, and our very last argon 18. Let us now name them. 11 sodium, 12 magnesium, 13 aluminium, 14 silicon, 15, 16, 17, 18. That is, those are our period 3 elements. So if I can say an element is in period 3 of the periodic table and it is in group 8, it will be this: period 1 to 3, starting from here for hydrogen, period 1 to 3. And in group 8, group 1, 2, 3, 4, 5, 6, 7, 8, argon. So the third column or the third row is the period 3. Okay, good. We are up for this energy levels. Starting with the energy levels, you have just said that group period 3 elements have 3 energy levels, so there's no much discussion here. All of them got 3 energy levels. 3 energy levels. Starting from sodium, let us write the configuration here since we'll be using it even later. Sodium is 281, magnesium 282, aluminium 283. Just an addition of 1 electron, 284, phosphorus 285, sulfur 286, chlorine 287, and argon 288. Like that. Now we have checked on the energy levels, and it can be seen that every atom of those elements, every atom has an energy level, an electronic configuration with 3 energy levels: 281, 282. Only that they keep on adding 1 electron to the end of that period. That one is said atomic and ionic radius. Yes, atomic. Let us start with atomic radius. And this one should apply all through, but we can just pick some two random elements, atoms of elements. We just pick two random, maybe sodium and sulfur. You can pick two random elements and then find out how the atomic radius varies. Yes, we find out how the atomic radius varies. After that, we can talk of the atomic radius and then compare them. But let us pick, as we have said, let us pick sodium and sulfur. Sodium and sulfur. Good. This is atomic number 11. This is atomic number 16. Configuration 281, 286. They both have 3 energy levels. Therefore, sodium 2, that is the nucleus of sodium, and then 2, 8, 1. The nucleus of sulfur is over there. So they have the same number of energy levels. 2, 8, 6. They are not of the same size. I have not drawn them to scale, so we'll be discussing and finding out which one is bigger than the other one. Let us indicate the electrons. This is 2 and then 8. 1, 2, 3, 4, 5, 6, 7, 8. 1. 2, 8, 6. 2, 8, 6. 1, 2, 3, 4, 5, 6. And since it will do it in the long run, let us draw the ions here. The ion of sodium. I will be borrowing some knowledge from what we have already learned, so I won't be doing so much on things. I mean, this one uses one electron to form an ion. It will be 2, 8. 2 and then 8. 1, 2, 3, 4, 5, 6, 7, 8. And for sulfur, it won't be losing because it will require a lot of energy to lose 6. Therefore, it gains 2 electrons. So, on gaining 2, the configuration changes from 286 to 288. From 286 to 288. And therefore, it will still have 3 energy levels. Yeah. Sulfur 2, 8, 8, 2, 8, 1, 2, 8, and then 8, 1, 2, 3, 4, 5, 6. I just said that it has gained 2 electrons. Let us show the gained electrons in this color. That is it. Now, we want to talk of the atomic radius and the ionic radius. But before that, let us say that this group contains, you see, when you are talking of groups or families, chemical families, you are talking of elements that have similar properties. Yes, you are talking of elements with similar properties, like sodium, potassium, and lithium. They are elements from the same chemical family. They have the same properties. Even the chemical properties that you have not talked about, they react the same, maybe producing the same product as sodium reacts, potassium reacts the same way, and lithium reacts the same. That is one. Also, the physical properties like melting point. We talked only that it varies. We talked of conductivity. They do it all along because they are metals and they have the same properties. That is why they are grouped in the same family. But when you come to this period, this is a period crossing from the left side to the right side. We have they vary, even the appearance, the state in which they are, all through they vary. How? This is a metal. Sodium is a metal. Good. Magnesium is a metal. Aluminium is a metal. Silicon is an nonmetal. And then it is a nonmetal. It has some properties of metals. We said it's a metalloid. It has both properties of metals and nonmetals. But these three are metals. From here, these are nonmetals up to the end. They are nonmetals. And to show even how much they vary, the last two, chlorine and argon, are gases. So they are in different physical and chemical, they have different chemical and physical properties. But now this is what you want to check, the properties. I said that because I just don't want to conclude here. And first we can talk of, because we are talking of the atomic sizes, I wanted to see if maybe the metals are different from this, but it is not the case. It will be all through. When you talk of atomic sizes, it will be all the way from sodium to argon. We can talk of the trend, how the trend over there. So let us continue. And we will see that we are checking of the atomic size of this group 3, sorry, of period 3 elements. Atomic sizes of period 3 elements, or atomic radius. We have sodium here and we have sulfur. Remember, it is not the case that we had earlier between maybe lithium and potassium, whereby lithium had 2 energy levels, potassium had 4. Lithium had 2, potassium had 4. It is not the case now. Both of them have the same number of energy levels, 3, 3. It is like a draw. Okay, 3, 3. And then the question is, which one is bigger than the other one, or how does the atomic radius change across this period? And the answer is simple. We'll be looking at the balance of protons and electrons. And at that point we will say that sodium, let me draw yet another one here. Sodium has 11 protons, or 11 positive charges. Sodium has 11 positive charges. This is positive. And then we have these energy levels, which contains 11 electrons. Let us compare it to sulfur. Sulfur has 16 protons, or 16 positive charges, and then it has 16 negative charges, or electrons. Yes, both of them are balancing. Yes, both of them are balancing, and everyone can see that it is 11, 11, 16, 16. But now let us talk of the nuclear charge again. The nuclear charge, it is how strong is the nuclear pulling the electrons in the shell? How strong is it pulling? And for this case, for sodium, we only have 11 protons. That's not quite large. In fact, it has the smallest in this group, the smallest number of protons. So in this case, the nuclear charge is not that strong. Only 11 protons pulling 11 electrons. And to add on it, they have the same number of energy levels, meaning that the very last electron is at this distance. The same case, the distance of the last electron is the same. The shell, it is in the third energy level. But even if they have the energy levels, sodium over here has only 11 protons, but its partner here, sulfur, got 16. It got more, pulling a number of electrons the same distance, or maybe in the same energy level, just like sodium. And therefore this attraction is more. The attraction here is more. If we had argon, the same case, it could have 18 here and 18, but it is pulling from the same energy level, that energy level. That is the maximum the electrons are. And therefore, in this case, this one has a higher nuclear charge. It has a high nuclear charge. And even if there is an increase in the number of electrons in each of these atoms, an increase, they all are going to the third energy level. Yes, they keep on increasing, but they are going to the last energy, the third energy level. In which it is in third energy level, that, like that. But also, there is an increase in the number of protons, resulting to a higher nuclear charge. Aluminium has 13 protons, sodium has 11. These ones of aluminium are being pulled more than those of sodium. And therefore, this is smaller than this. This one is smaller than this, and therefore what we say? We say that the atomic radius, that is what we are talking about. We have said that these ones are smaller. It goes on decreasing because the number of protons is increasing, pulling electrons in a third energy level just like the others, but with a higher nuclear charge. And therefore, the atomic radius atomic radius increases atomic radius increases we won't say now down the group, we are in a period from this part here, this is my left hand side, from left to right. That is the trend. The atomic radius increases from left to right, and the reason is what we have discussed here. This is because of an increase in the number of protons that results to a higher nuclear attraction. It is because of the increase in number of protons. Yes, we don't deny that electrons are increasing, that is true, but since they are increasing on the very last energy level, the third one in each it is the third one, they are pulled more because also the number of protons are increasing, they are pulled more. So the atomic radius increases from left to right. That is how we discuss about periods. You say from this direction to this direction, someone will say from right to left, but now let us prefer using maybe left to right. The atomic radius increases from left to right this way. The reason, because of the increase of the number of protons that results to a higher nuclear attraction. Let me read to you the definition that I've written here a bit fast. Atomic radii decreases across the group. Decreases. Yes, that is what you have seen. Oh, sorry, no, I said increasing. You said that this one is smaller. It is good that I checked. It is not increasing. You have said that sulfur is smaller. It is pulling more. So sorry for that. Make sure you change it. It is decreasing. Because you have said the charge is more, it is pulling them more. So of course, you have seen how maybe one can make a mistake. You say, I believe I'm reasoning it right. Yes, of course I'm reasoning it right, but I end up saying increasing instead of decreasing. It is decreasing. It is good that I had written it here. Atomic radii decrease across the group. Decrease across the group from left to right. From left to right. Due to the increase in nuclear charge. Due to the increase in nuclear charge, as you have seen it, that an increase in number of protons results to an increase in nuclear charge that holds the electrons in the last energy level more firmly. Holding the electrons in the last energy level more firmly, hence pulling the electrons more closer. Hence pulling the electrons more closer. That's a very good definition. Yeah, you're done with that. Done with atomic radius. Let us now mention about the ionic radius.